Welcome, Entri. I'm Vivek Chari. We are discussing as an electrical circuits part for both EEE and ECE students. Okay, we have more than 30 years of teaching experience, and I taught circuits many times. So definitely it will be useful for you. And one more important point is this electrical circuits is the basic subject for all other subjects. Like EC people also, most of their subjects, EEE, almost all core subjects, it is a compulsory basic subject. Every topic, whatever I am explaining in these electrical circuits, is somewhere linked to some other subjects of the core branch or your concerned branch. So this is a very, very important topic. You can't leave any of these topics. Be concentrate, and definitely every content and concept of this particular subject is useful for you in some other areas of, and even in this subject also for remaining units also. This is a fundamental unit. Okay, so please remember, all of you, I would like to explain one by one the circuits. Generally, EEE students will call it as circuits 1 and 2 like that, and EC they will call it as network analysis. But most of the 70% of the syllabus is same for both EEE and ECE. We will discuss the common topics which is useful for both ECE and EEE students. Okay, generally I would like to show the name of this scientist, Simon Swam. He introduced this concept of I is equal to E by R. In generally, here I would like to generally concentrate one important point here. Nobody will ask directly a simple question like this as a competitive exams. But the current is proportional to voltage or voltage is proportional to current. Here people will get a small doubt. In generally, I prefer current is proportional to voltage. Why? Because I have a voltage source from the market or from a purchasing shop. I will purchase a battery or a voltage. Once voltage is there, if I apply to load, a current will pass. Please see the logic. Suppose I have a load. This load may be either Ohm's law or pure resistor or inductor or capacitor, whatever it may be. And I have a source like this. Whenever I am connecting this voltage source, then only a current will pass. Yes or no? Suppose it is a resistor, suppose. You people say I is equal to V by R. If I having a variable voltage source, that means I can increase the voltage or I can decrease the voltage. Then proportionately the voltage is increase or decrease, the current will vary. But you can't give a current source directly to a resistor. Can you hold this type of circuits? It is only ideal we are replacing a current source and resistor, and this is called voltage across the resistor. What is the difference between this circuit and that circuit? Same. Here a voltage source is connected across the resistor, a current source is connected across this voltage source. Generally, what is the formula of this V is equal to I into R. Here, what is the formula for current is V by R. I don't want to make you confused in the very fundamental topic, but more accurate is I is V by R. Why? Because in the market, voltage sources are available. You can ask a 1.5 volts battery, of 3 volts, 2 batteries. 6 volts, 4 1.5 batteries, or 9 volts direct batteries are available. So my intention here is this voltage source is physically available. So I can increase or decrease the voltage levels by purchasing more batteries or lesser batteries. You know, a series of cells will give you a battery. So I can have number of cells in series to get the resultant voltage, whatever the voltage I want. So I can increase or decrease or decrease proportionately, it will also increase or decrease the current. So the current is proportional to the voltage. Generally, usually we will say voltage is proportional to current. But can you go and ask in the shop, give me 2 amps current source or 1 ampere current source? You can't ask. Once the current is given to a resistor, it will give you a voltage, but it is not possible. This is theoretical, but this is practical. Really available in the world. Current sources are not directly available. So based on this concept, I told you the current is directly proportional to the voltage and I is equal to V by R. or voltage is directly proportional to current. If current sources are also available in the market, then V is equal to IR. Both are correct. But this is more correct, you remember. Generally, what is the Ohm's law? The current passing through an element is directly proportional to the voltage across it. Voltage across it. Or the voltage is directly proportional to the current passing through it. Both are correct. At constant temperature. You people know very well from your intermediate itself the impact of temperature. Okay, so current is amperes, voltage is volts, and resistor is in ohms. But this is the 18th century, 19th century itself, it was discussed, we are discussing in the 21st century. Okay, so then generally these are the SI system we are using for the throughout the entire engineering subjects. Throughout the engineering subjects. So I would like to give you a brief revision. So generally we are having meters, kilograms, seconds and amperes is the general system. MKS, everybody knows this very well. In the ampere also Kelvin for temperature, mole and candela, don't worry about all these things. And we have to derive these units of work or energy, power, also like this. What is the meaning? These are also to be discussed here. For work done, we can say joules. And for power, we can say watts. And 1 watt is equal to 1 joule per second. I will give you later on one by one. The power is equal to work done per second. Work done or dW by ds. I will tell you all these things in the later slides. Generally, you know, nano, micro, milli, kilo and mega. We will go maximum up to this level for our resistors or inductors or even capacitors. Okay, charge. You people know very well an electron will have a negative charge minus 1.60 10 power of minus 19 coulombs, and a proton is having 1.6 into 10 power minus 19 coulombs. You people know this very well. Okay, I don't want to discuss much on this. You know the charge units are coulombs. You people know this very well from your fundamental basics. Okay, charge. Generally, this is the actual Ohm's law. A resistor is taking a current passing through this, you will get a voltage V. Here, nobody will tell you the actual concept. This is called a two terminals A and B. What is meant by A and B? Between any two terminals, suppose there is a big circuit is there. See here, this is a very big circuit. Between two terminals like A and B, suppose some resistor is there. That means this may have many number of elements. It may also having many number of elements. We don't bother about that. But you can see a particular resistor is having some current. It is allowing some current I and it has some voltage V here. Then we can say the concept called V is equal to IR. We can explain the voltage is equal to I into R. And you people know the units of resistor is ohms, volts and amps. Anyway, we discussed this already. Here the very, very important point is, see the pink color all of you. Current is always passing from plus to minus. Higher potential to lower potential. Higher potential to lower potential. You know, water also flowing from higher level to lower level. Current also passing from higher potential to lower potential. Earth or ground is generally zero potential. And we are generating the EMFs with some 230 volts, 415 volts like that. They are called generated voltages. Higher potentials. So, voltage is a potential difference. Higher potential is 230, lower potential is 0. What is the voltage? 230 volts. So, the higher potential is 230, lower is minus 230. What is the voltage? 230 minus of minus 230, 460 volts will come. Please do not confuse the simple fundamental basics. Okay? Now, observe carefully here. This is point A and point B. Between any two terminals, either supply or by current flowing. You may give supply here, or because of the circuit some current is flowing, and because of this current the voltage is equal to I into R. Current is flowing here, voltage is calculated here, such that higher potential to lower potential. Suppose if I say here the current is passing, suppose Ix from B to A. What is the meaning of this? If V is equal to IR or I is equal to V by R. We accepted this. So what is the Ix or IR's relation? Simply we can say this is minus Ix, that's all. This is also correct, this is also correct. So in the entire syllabus, if the direction is reversed, you please should not afraid of. Don't be confused. In the any topic, anywhere it occurs, you people should not confuse. A current is passing like this from higher potential to lower potential. But lower to higher, suppose any current is taken by chance, by selection, Ix passing from B to A, then this Ix is negative of I or I is negative of Ix. Both are correct. Suppose this is having 3 amps. Then what is the Ix? Can anybody say? That is called minus 3 amps, that's all. Nothing is wrong here. It is also correct, that is also correct. And this Ohm's law is applicable even under temperature constant condition at any point in this one. Suppose here between C and D, this is called C, this is called D. Between C and D, some resistor is there. Here also current is flowing, voltage is defined as V is equal to IR. So any network, irrespective of what is the sources, what are the elements, what are the currents flowing, particular element if you take between the two terminals, nobody will say in any formula. Okay? A resistor of an element where the constant R is a resistance. Okay? So the action is, the equation is given as Ohm's law mathematical. I don't want to discuss much on this. Just I would like to show you, nothing is there here. The resistors may be like this. You people know very well how to calculate the value of resistors. Okay? You know that Great Britain, BB Roy. Okay? BB Roy, VGW, Great Britain. Okay? Na? You people know that coding system very well in the lab also. And some area resistors are there shown like this, and somewhere resistors are shown like this. Anyway, this is only just to see this. And why it is called a linear element? In the previous slide, I told you a meaning of linear. What is meant by linear? Generally, this is called a straight line. What is meant by straight line? If you draw a relation between voltage and current of a particular resistor. This everything is explained for a particular resistor, what is the current and what is the voltage V. You see, anytime I am writing plus 2 minus is the standard way for direction of the current and corresponding voltage. Are you following, all of you? So please remember here, suppose if this is here, R is, suppose V is equal to 1 and a particular point here. This is giving a corresponding voltage. Similarly, if it is 2 here, somewhere here the voltage is shown. And similarly, somewhere here 5 is there, you may get some voltage. So what is the slope here? Please remember, this slope is called resistor. Slope is equal to resistor. What is meant by slope? y2 minus y1 by x2 minus x1. One is default 0 and manam teeskunnamu ante, then any other point, 5 divided by, this is current and this is voltage. So this is the voltage divided by corresponding current, you will get the resistor. Okay, voltage divided by corresponding current. Why? Because what is the resistor? V by I. Any point you can take. Suppose this is a point, I am selecting here on the straight line. So this particular is called V and this particular is called I. Then that V by that I is gives you that resistor. Or if I take as a point wise, this is called voltage and this is called current. Then here V2 minus V1 by I2 minus I1. Here voltage is x-axis is shown, but it must be y-axis according to formula. Otherwise, a reverse of the slope will come here. You have to calculate like this. If the slope is taken, I by V will come. That is called actually conductance G. The slope actually defines conductance. So V by I, x-axis by y-axis if you are taking, it is called reverse slope. But y is shown here and x is shown here, it is clear. Don't be confused for this. Always voltage by current. Finally, what is my intention here is, how can you say it is a linear? The relation between voltage and current is always a straight line. Straight line means it is not like this, or it is not curve like this, it is not curve like this. It must be a clear cut straight line. That is the showing the linearity. So resistor is a linear element. It will be discussed later in theorems, KVL, KCL, mesh and other analysis methods. Definitely it is useful. You remember resistor is a linear element or not. Definitely it is a linear element. Now come to this power. The power is generally, we are discussing in generally, it is the rate of doing work. Sometimes the work done is also called energy. Both are same. But clearly you remember here, another way it is defined as voltage multiplied by current is also power. If you replace this voltage by I into R, see here, if it is replaced by IR into I, you will get the I square R. Or if the V is same and I is written by V by R, then V square by R is also correct. You may get number of formulas for power. Even simply if you know the energy also, suppose, okay, right, you can calculate all these values. Okay, so you can calculate the power in one of these methods. You can easily calculate. Okay, if the depending upon what is given and what is not given. This is same. Resistor voltage, current, directions, polarities, everything is same.